This is Libby, and I'm going to be talking about exchange surfaces today. Exchange surfaces are surfaces that are adapted to maximize the efficiency of gas and solute, a substance dissolved in a liquid, exchange across them. They have the following adaptations. So first of all, a thin membrane. A thin membrane reduces the diffusion distance, so it can happen more quickly. A large surface area. A large surface area allows more of a substance to diffuse at the same time. Again, so it will be more quick. Ventilation. In animals, if a gas is exchanged, the surface is ventilated through breathing to maintain a high concentration gradient and increase the rate of exchange. And blood supply. Where substances are exchanged through blood in animals, exchange surfaces are densely packed with blood vessels. These blood vessels replenish the blood supply to maintain a high concentration gradient by bringing in new blood as diffusion starts to even out the concentrations. So this ensures there's always a steep concentration gradient so diffusion can happen quickly. Okay, so let's just recap on what we've just learned. We know that exchange surfaces are surfaces that are adapted to maximize the efficiency of gas and solute exchange across them. So let's consider some examples of exchange surfaces. Some examples of specialized exchange surfaces include the small intestine. The small intestine can be seen here. It's adapted for exchanging nutrients between digested food in the small intestine and the blood. The lungs. The lungs are adapted for exchanging carbon dioxide and oxygen between the blood and air. The gills. Gills are adapted for exchanging oxygen that is dissolved in water with the carbon dioxide in a fish's bloodstream. So this is what allows fish to breathe underwater. Roots. Roots are adapted for taking up both water and minerals from the soil around them. And leaves. Leaves are adapted for exchanging carbon dioxide and oxygen between the leaves and the surrounding air. So what is the small intestine adapted for, as we've just learned? It's adapted for exchanging nutrients between digested food in the small intestine and the blood. So let's just recap on these specialized exchange surfaces. They include the small intestine, the lungs in mammals, gills in fish, and roots and leaves in plants. So, what are the adaptations that exchange surfaces tend to have, which we learned right at the beginning of this episode? So, a good blood supply, a large surface area, a thin membrane so the diffusion distance is small, and ventilation. So let's just look back on the lungs, which we just learned about as a specialized exchange surface in mammals. Lungs have a very large surface area, which, as we just recapped on, is an exchange surface adaptation. This allows maximum diffusion of oxygen into your blood and carbon dioxide into the air. So we know that roots are a specialized feature in plants specifically. They're designed to take up water and minerals, and they have a large surface area. So that's everything for today with exchange surfaces. Thank you very much for listening.